Hello everyone, welcome to yours and my favorite part of the week. That's right, it is your online general psychology lecture, and I'm here to walk you through the hottest topics in general psychology. Before I jump into this and really get into our course material at all, again, I want to welcome to the course. And kind of just give you again, kind of a broad overview of how we're going to approach this course. I'm really trying to structure this course in such a way that emphasizes kind of scientific literacy. So working on your understanding of science, what is science, how to do research, how to think critically, and kind of not just how to do research, but also eventually kind of do your own research. Specifically, I'm kind of designing this general psychology course to bridge over to my developmental psychology course, wherein kind of the final project is like this is kind of independent research, kind of lit review event. You'll worry about it, a year from now. But kind of the idea here in general psychology is get your feet under you. This is a very broad course. I tell other in higher level psychology courses, I tell my students each one of these paragraphs, specific researchers will dedicate their entire life to trying to understand this single paragraph of cited information. This single finding, researchers will spend their entire career trying to support it or find evidence not supporting it. And in this course here in general psychology, it's that on steroids. This is a very broad overview of the entire scope of psychology. So it's going to be kind of a training wheels situation. Get your feet under you to get kind of familiar with these broad concepts across all of psychology, at the same time developing those critical skills and that focus on development of those skills. Again, kind of your scientific literacy, your reading, your writing, independent research, and then also cultivating your intrinsic interests within psychology. So things that you find interesting to you, providing you with opportunities to further explore those interests within this course. All right, so with that said, let's jump into it. Just some quick true or false questions, / the answer's already here. True or false, most people use only 10% of their brains. That would be false. The lie detector polygraph test is accurate 90 to 95% of the time. That is also false. And then also kind of a little bullet point I wanted to highlight. Only 30% of Americans agreed, quote, psychology attempts to understand the way people behave through scientific research. 52% of Americans believe that psychology, quote, attempts to understand the way people behave by talking to them and asking them why they do what they do. Well, that is not correct, and really kind of speaks to a really fundamental misunderstanding of what psychology is in the general population. Even though it's widely talked about, you have kind of pop psych terms floating all over the internet, all kinds of self-help books, kind of new buzzwords that pop up on TikTok or whatever. You got your toxic stress and empath and all these kind of psych terms that kind of bounce around that are really not defined well, and kind of reflecting the fact again that many people do not understand that psychological findings are kind of conducted through experimental studies. That's how that information is done. While versus kind of like the classic kind of almost Freudian kind of understanding of basically counseling really is how people conceptualize psychology. But we're going to investigate kind of what really is psychology. So jumping into what is psychology? Psychology can be defined as the scientific study of the mind, brain, and behavior. As a discipline, psychology spans many levels of analysis. It runs from biology to social influences. We can't understand psychology by focusing on only one level of analysis. Instead, we need to examine all of them. APAs, that is the American Psychological Associations. 54 divisions are interest groups organized by members. Some represent sub-disciplines of psychology, while others focus on topical areas such as aging, ethnic minorities, or trauma. So kind of the idea here is, starting off with this definition, a scientific study of the mind, brain, and behavior. Now, a big part of this class, and I'll start at day one here, is it's always important how you define your terms, because scientists, scholars, psychologists do not agree on the same definition for terms. And you'll see this throughout your time in psychology courses, or even if you only take these psychology courses, or if you keep studying psychology in the future. Scholars argue about the definition of terms. So literally, what is the mind, for example? That's a very broad one. But even something simple as what is personality? That is hotly debated. So each psychologist, these different theories, these schools, approaches to psychology define these terms differently. So ultimately what really happens is different kind of approaches to psychology, again, different theoretical approaches have their own definitions of terms, but also there is basically a need to define the term so then that everybody can test, can conduct research on those terms. So if I can't define what personality is, there's really no way to test it. You have to define those terms first. So therefore, each of these kind of constructs in psychology have something called operational definitions. So that's basically a definition that we're using for the purposes of this study. So therefore, we can conduct research on them, and then other people can conduct research on them in a semi-coherent way. So it's important to operationally define your terms. So here's psychology, the scientific study of mind, brain, and behavior. That is one definition, and that's a specific operational definition, which is good enough. This is the kind of the approach to this. And kind of walking through this a little bit, as stated, psychology spans many levels, and those go all the way from kind of the neuron all the way up to the neighborhood, which I'll discuss in the next slide. But you can see on this slide here, kind of this theory, which we're really not going to talk about right now. We're not testing on it. Again, this is kind of just a general overview. This is something called these Bronfenbrenner levels. Again, you're not testing on this right now. And the idea here is basically all these different variables that you see here, laws, countries, neighborhoods, families, all these things interact together to impact psychology, to impact behavior, the mind, and the brain. And reflecting kind of that, how many different variables are interacting to impact psychology, the APA, again, the American Psychological Association, has 54 divisions of research, ranging from aging to trauma to sports, counseling, you name it, they got it. So that, again, kind of speaking to the breadth and the amount of research that psychology encompasses. Levels of analysis. Think of levels of analysis as rungs on a ladder, with the lower rungs tied most closely to biological influences. The higher rungs tied most closely to social, political, and economic and cultural influences, from neurons to neighborhoods. To fully understand psychology, we must consider multiple levels of analysis. Each level tells us something different, and we gain new knowledge from each perspective, like an elevator. So kind of the idea here is that, as stated, there's these levels of analysis working from all the way up to the country, the state, your hemisphere, the historical era that you live in, versus all the way down to a single neuron, the measuring potassium and salt, specific neurobiological hormones. Stuff like that. So all from microscopic all the way up to like conceptual historical period. And each of those levels, each of those explanations of behavior have different kind of strengths and weaknesses. They tell us something different, new knowledge. Looking at a neighborhood is different than looking at a neuron. Looking at the amount of, whatever, I'm just making up something. Looking at something, the amount of dopamine in someone's brain versus the amount of healthy grocery stores in the neighborhood. Both of these things can influence our understanding of behavior, of psychology, but through different lenses. And kind of the general argument is to fully understand psychology, you should consider multiple levels of analysis. Now, each researcher typically focuses only on a couple of these levels, thus kind of they work in teams to anytime there's kind of like a very complex study wherein they're collecting biological data and, again, kind of those larger cultural, country-wide sources of data. Again, speaking to the depth of psychology, not just like this idea of laying someone out on a bed or a couch and then asking them their questions. Rather, this a multi-level scientific approach to the analysis of behavior. And right off the bat, you should know, you should quickly understand and notice that, hey, that's pretty difficult. Human behavior, understanding it is difficult, and predicting human behavior is difficult. Some of the reasons include they are determined by multiple factors. That is, behavior is caused by many factors. Psychological influences are rarely independent of each other. Women who are perfectionists also tend to be anxious, to exercise a lot, to be overly concerned with their body image, to watch television programs that feature thin models, and continuing on. People display individual differences in thinking, emotion, and personality. People can respond differently to the same stimuli, such as getting yelled at. So, kind of as stated before, we have these multiple levels of analysis, which is, cool. I can look at all this stuff from the neuron all the way up to the historical era, but that is very complicated. Designing research studies to measure all those variables is impossible. But to even measure specific ones and then to rule out alternative hypotheses is challenging. Psychology influences are also rarely independent from each other. So as stated here, what you're kind of seeing here is that all these kind of variables are often intercorrelated. So, kind of looking at eating disorder research, perfectionists are more likely to be diagnosed with an eating disorder, but those people are also more likely to be anxious. They're also more likely to be overly concerned with their body. Then they might be, and because of that over concern, then they might seek out television shows that feature thin models. So you have these kind of all these behaviors being all closely correlated with each other and all reinforcing each other, making them stronger, thus trying to kind of pinpoint and kind of disentangle those very correlated behaviors can be quite challenging. People display individual differences. So I can present you with a specific stimuli. So for example, whatever. I say I leave you some feedback on your discussion posts, and it's the same feedback I leave every single other person. Just making this up. And then you get the feedback, or one person gets the feedback, and they're like, "Oh, this is great. This is great feedback." And then another person gets that same feedback, and they're like, "This is the worst feedback I ever got in my life. I hate this dude. I'm dropping this class, and I'm going to, and I don't know. I will gossip about him or something. I don't know." But kind of the point here again is that you're presented with the same stimuli, but people can respond differently to that same stimuli. So again, difficult to measure and difficult to predict behavior based on just a single stimuli being presented. Another is reciprocal determinism. We mutually influence each other's behavior. If you're an extroverted person, you're likely to make the people around you more outgoing. People's behaviors are shaped by culture. Cultural differences, like individual differences, place limits on the generalizations that psychologists can draw about human nature. Researchers showed people a photograph of a tiger walking on rocks next to a river. The researchers used eye-tracking technology, which allows researchers to determine where people are moving their eyes. The researchers found that white Americans tend to look mostly at the tiger, whereas Chinese Americans tend to look mostly at the plants and rocks surrounding it. Evidence suggests that white Americans tend to focus on central details, whereas Asian Americans tend to focus on peripheral or incidental details. All right, so kind of, again, walking through this here, reciprocal determinism. The idea, going back to that example, you're an extroverted person, you're likely to make people around you who are more outgoing. So I'm extroverted, so I'm going to go to the club, I'm going to talk to people, I'm going to probably run into other extroverted people doing extroverted things. Therefore, my behaviors, my psychology then, is being reciprocated by the environment around me, not just mine, and that environment includes other people and the bar or whatever. And in that moment when I'm at the bar, partying or playing, singing karaoke, and people are jamming along, we at that moment are reciprocating our extroversion. So it's kind of difficult to pinpoint, oh, that person is naturally that way, is always that way, because constantly we are interacting with each other. We exist within a social world. So it's, again, difficult to predict behavior. People's behavior is shaped by culture. So cultural differences exist across the world, and it impacts our psychology. It literally impacts our brain development, our genetic expressions, our behaviors. So, for example, in this study of this tiger, researchers had Chinese and white Americans put on this eye tracking technology again. That basically all that does is you put on this device and you can see super accurately where a person is exactly looking, for how long they're looking, the sequence of where they're looking, all kinds of complex stuff. And what these researchers found is that on average, white Americans tend to look more at the kind of the subject of the image, in this case the tiger, whereas Asian Americans really take in those peripheral and environmental factors. Literally a different way of looking at the world, and thus you're going to kind of take in different information. And that different way of looking at the world really reflects kind of differences in culture, so kind of collective attitudes, different really understandings of the world that we'll get into a little bit in this course, but will be discussed in more detail throughout your time at our psychology course sequence. Okay, moving on to why we can't always trust our common sense. Most of us trust our gut intuitions about how the world works. To many, the proverbs listed on the right all ring true. However, looking right across from each other, each proverb contradicts each other. Our common sense can lead us to believe two things that can't be true simultaneously. And this kind of goes back to what I talked about in the beginning here. We have kind of preconceived notions of what psychology is, but also because we kind of live in the real world, psychology is kind of a field wherein every single person feels like, well, I have an understanding of human behavior. And they do. They have their own theories of human behavior, different understandings of the world. And they have to, because in our institutions, in our everyday life, everything around us revolves around me having an understanding of how humans interact with each other. What is humanity? How do I expect the world to operate? I have certain assumptions of humanity. And countries and states and cities, neighborhoods, schools have certain assumptions of human behavior that are reflective in their institutions. So whatever, if I thought like, oh, humans are, the worst and like they're hopeless or whatever, then I'm not going to give them like a lot of freedom or something along those lines. And you can do this for any historically disenfranchised group, really. It's really our assumptions of humanity or their non-humanity. That really kind of dictates our everyday behaviors and kind of the way we structure our societies. And here, going back to these proverbs, you see if you ask someone individually any one of these, they're most likely to say, yeah, I kind of agree with that. But there are other proverbs that exist kind of in the world around us that those same people will agree with. So a person will agree both with birds of a feather flock together and opposites attract. Because they've kind of had those real world experiences and they're like, yeah, that kind of both sounds real. So our gut instincts, our intuitions can often be misleading. So kind of the point here being that like that individual understanding of the world, those anecdotes that we rely on to interpret the world around us and make sense about the world around us can often be incorrect. So let's talk about some of those incorrect kind of gut intuitions, those reasons not to trust our quote-unquote common sense. Why can't we? And we're beginning with naive realism. It's a belief that we see the world precisely as it actually is in truth. Seeing is believing works well in ordinary life, but consider sun revolves around the earth. So basically what this is saying is what I see right in front of me is the truth of all reality. Now, of course, that relies on my interpretation of the reality around me. But also, the classic example is looking at, for hundreds, thousands of years, people believing that the sun revolves around the earth because they look up in the sky, I see what the world is, this is reality, I'm looking at it, I see it, it's right in front of me, it's common sense. And then that proved to be incorrect. The sun does not revolve around the earth. It's the opposite. So you cannot always rely on seeing is believing. You do need some assumptions to operate in the world, but when kind of drawing these broad arguments, these broad conclusions about behaviors and about the way the world works, you kind of need a more systematic approach. Another source of why we can't trust our common sense is confirmation bias, the tendency to seek out evidence that supports our beliefs and deny, dismiss, or distort evidence that contradicts them. Once you have a hammer, everything starts looking like a nail. That is, once we have a belief in mind, we tend to look for and find evidence that supports it. Preconceptions often lead us to focus on evidence that bolsters our beliefs, resulting in psychological tunnel vision. So this is kind of like a classic thing, you're getting into an argument with your friend, friendly argument or whatever, or maybe you get heated. Maybe you're like my family and get heated and start yelling about random facts. And then someone says, okay, I'm going to Google this. And then they search, say you're Googling, I don't know, whatever argument that you were making. So say you're arguing about, I don't know, the best spicy chicken sandwich, and you Google why Popeye's chicken sandwich is the best sandwich, and you click the link and you're like, bam, here it is. Here's my proof. So you're basically Googling literally why your argument is correct. You're searching for evidence that supports your argument. Through your terms, why Popeyes is the best, because I was just arguing Popeyes is the best. So I'm literally finding sources that confirm my pre-existing bias. So over time, while doing so, a person will just accumulate basically a ton of information that only supports their argument without seeing kind of the other side of the argument. And then, obviously that can be more serious than a spicy chicken sandwich debate. Because the internet, and basically all social media, is really kind of just a series of algorithms defined kind of to reflect our own pre-existing notions, our own, it's really kind of a confirmation bias machine. Like Google, for example, your Google page, if you're signed into your Gmail, will be will give you different search results based on your interests than mine. So kind of you're really, it's cultivating your personal interests and kind of reinforcing them. So it's, that can, if you have, are interested in, or really trying to learn about something new and kind of expand your horizon, it can be quite difficult because it's really just kind of pumping back in stuff that's really just reinforcing your beliefs. So kind of a challenge in the modern era of confirmation bias. And another classic example is looking at Dartmouth fans. These are kind of like Ivy League football. We're more likely than Princeton fans to see Princeton players as dirty and as committing more penalties, whereas Princeton fans were more likely than Dartmouth fans to view Dartmouth players in the same way. So this is kind of like classic sports head like kind of thing. The game's rigged against my team, so therefore I'm going to interpret the behaviors of the other team as cheating, as dirty. The refs are out to get me. I'm going to either I'm going to just watch the field, use my naive realism, see it for myself. I see it, they're cheating me. And then I'm going to go confirmation bias. Maybe I'll go into Twitter. Atlanta Falcons are being cheated. We didn't blow a 28-3 lead. We were cheated. Look for specific statistics or some kind of specific play or whatever to support my theory. But kind of, again, just a general example here of how this plays out in everyday life in sports. Pseudoscience. A set of claims that seem scientific but aren't. Pseudoscience lacks the safeguard against confirmation bias and belief perseverance that characterize science. In belief perseverance can be defined as a tendency to stick to our initial beliefs even when evidence contradicts them. So kind of the idea here is, so you're arguing with your family, and it's one of those moments where you're arguing for a minute, and then you realize, oh wait, I am actually incorrect. But in this case here, you wouldn't really come to that realization, or you would come to that realization and then just deny it anyway. So you have evidence presented to you that you are incorrect. There's been a scientific study somehow, and it's been proven that, which would not be possible, but stick with me, that the Wendy's spicy chicken sandwich is better than the Popeyes chicken sandwich. Boom. And then you say, no, I refuse to accept that evidence. In the real world, though, it would be something like, oh, I'm making this argument of, actually, no, we actually only do use 1% of our brain, but then someone presents you with a neurological study that shows you that that's not true, and then you just believe it anyway because, I don't know, you saw it in that one movie that I can't remember the name right now. So sticking with your, sticking with those beliefs, those biases, despite evidence that is contradictory. Overuse of ad hoc immunizing hypotheses. which is the escape hatch that defenders of a theory use to protect their theories from being not supported. ESP in the real world, like reading other people's minds or forecasting the future, when brought into the laboratory and tested under tightly controlled conditions, most have bombed, performing no better than chance. Ad hoc immunizing hypotheses to explain away their failures. The skeptical, quote, vibes of the experimenters are somehow interfering with psychic powers. Makes the psychic's claims essentially impossible to test. All right, so kind of a lot of jargon here. So basically what we're getting at, ad hoc meaning kind of just off the top of your head. You're making up as you go is basically what they're saying. So making up as you go, immunizing, so like I'm immune from being disproven kind of thing, or correcting myself, of being presented with information that challenges my theory. So making up as I go, immunity. So kind of the idea here is that after evidence is presented to you that would challenge your argument, what a person would say was like, oh, actually, it's kind of like, oh, actually, XYZ happened, so therefore it's actually not a valid critique, blah, 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 blah. And kind of a classic example of this is people who claim they can read other people's minds or broadcast into the future. You bring these people into a laboratory environment and have them complete tests that would test their ability to forecast the future, read other people's minds, and they do not perform better than chance. Shocking. And then you ask, and then how they will explain that away is they'll say something like, "Oh, the vibes in the room are off. The room is kind of unsettling. The experimenter's unsettling. It's knocking off my powers," which, I mean, may be true, but ultimately is impossible to test. So it's not scientific. It's pseudoscientific. You can't test it, and kind of these explanations can just keep new explanations can just be generated continuously, kind of to support the idea that they are ESP and I'm incorrect, even though I found out that they are unable to predict the future in a laboratory setting. Continuing on, features of pseudoscience: lack of self-correction. Many scientific claims turn out to be wrong. In science, however, incorrect claims tend to be weeded out eventually. Most pseudoscience mistaken assertions never seem to go away because their proponents fall prey to belief perseverance. That is, again, clinging to arguments despite contrary evidence. Pseudoscientific claims are rarely updated. So kind of a big flaw with pseudoscience is kind of a tall tale sign of pseudoscience is a lack of self-correction. So in the science, there can be very bad peer-reviewed scientific journal articles. There can be just shit that's published. There can be things that do not replicate or end up being false. But kind of the point of science is that through time, using this kind of systematic approach to analyzing data, to forming hypotheses, using proper control groups, having basically standards that you adhere to, you can kind of weed out those bad findings over time, because other people will also be testing that measuring that same scientific question, and thus you kind of get a bunch of different data, and then you can kind of analyze the data, all these different studies together, and then kind of form a global conclusion and make corrections, and theoretically kind of update our understanding of psychology or anything really, any field, with time. Thus why you can't really use a psychology textbook from like 1980, because since then we've discovered a bunch of shit. Now granted, the differences between a 1918 textbook and a 2018 textbook and a 2020 textbook, okay, that's, you know, those are publisher just gouging. But kind of the principle though is if it's 40 years old, a lot of things have been learned since then. That kind of reflects how science, theoretically, and the best case scenario is working to weed out incorrect information and strengthen our arguments and our understandings of any science, in this case psychology. Pseudoscience also over-relies on anecdotes, and one specific version of this is kind of plurality, very easy for me to say, of anecdotes. So you can say, oh, my friend saw this, I saw this, or I see this same thing every single day. So the plurality of my own individual anecdotes kind of acting as like a substitute for like a well-researched multiplicity of studies. So kind of like a ton of studies versus kind of a ton of observation. And kind of the point here is ultimately that the plural of anecdote, multiple anecdotes, isn't fact. Just because you see it a bunch of times doesn't mean that it is factual in any way. It just means that you've had that experience multiple times. And there are two typical types of anecdotes. The first-hand evidence, such as I feel less depressed after taking this herbal medicine, versus second-hand evidence. I know a person who says his self-esteem skyrocketed after receiving hypnosis. So you kind of have two sources. You have your own individual experiences, and you have your own friends, who your friends are also kind of typically going to be like you. So kind of reinforcing your own assumptions and your own anecdotes, kind of going back to that reciprocal effect that I talked about in previous slides. But so kind of those are our two sources. And then anecdotes also don't tell us anything about how representative the cases are. It's difficult to verify. So tying together the over-reliance bullet point and this bullet point, kind of the idea is, say I'm super rich and everyone around me owns limos and they ride horses all day. And every single day I go outside, I see everybody has a limo, everybody has a brand new car, everybody has 10 horses. So that's a plurality of anecdotes. I see it every single day. But you know, that's not a scientific way of observing data, because one, the plurality of anecdotes aren't fact, and two, my anecdotes don't tell us anything about how representative the cases are. What I mean by that is my rich neighborhood, is that the norm? Is that representative of the entire world? Is that how most people live their life? Maybe, maybe not. And spoiler, obviously not. But I don't know that. I just see the world around me. I accept the world around me as reality. Everything's great. Everybody has horses. Everyone's rich, and that's reality to me. So that's why you can't rely on those naive realisms, those anecdotes that just because the plurality of anecdotes due to how that method not being a scientific way of understanding the world, because obviously everybody does not have horses. So then the question becomes why? Why are we drawn to pseudoscience? Some argue that our brains are predisposed to make order out of disorder and make sense out of nonsense. So kind of the world around it, we have to operate on assumptions. We can't stop every 1 second and be like, okay, I'm calculating this. What does the research say on this? I have to live in reality. There's all kinds of stimuli constantly coming at me. I have to interpret the world around me in some way to exist. Which is, can generally be good, but also can present challenges, as kind of reviewed. One example of this, of making meaningful information about disorder in the world around us, drawing incorrect conclusions, is looking at a cloud. We all can look at clouds and then see different images. We're making meaningful images out of meaningless visual stimuli. And we can also draw those similarly, I should say, we can draw similar incorrect conclusions based on, and make meaning out of just random shit that exists around us, or draw incorrect conclusions based on our own anecdotal, very narrow life experiences. We also believe in pseudoscience because we want to believe that, quote, hope springs eternal, may give us comfort because they seem to offer us a sense of control over an often unpredictable world. So studies have found that basically if you kind of prime a person, or what I mean by that is kind of make a person or ask a person to kind of imagine a scenario where they're helpless, or really just kind of trying to interpret, a scenario where they're hopeless, where they can't really understand the world fully, so things are going around, are happening around them. They really don't have an explanation for it. They're kind of powerless. And pseudoscience kind of, in those studies, I should say, when they're exposed to kind of those scenarios, participants are more likely to adhere to pseudoscientific beliefs. So kind of the argument here is that in the midst of chaos, feeling a lack of control, everything around us is falling apart, people will cling to some source of stability, something that can at least give them a narrative to help them understand the world around them. So kind of a way to empower themselves through kind of in an unscientific way. So kind of really a quest for hope and then kind of an understanding of the world is one argument. Learning to think scientifically can help us avoid falling prey to pseudoscience. Bandwagon fallacy, for example. Lots of people believe it, so it must be true, valid, / good. Not me fallacy. Other people may have those biases, but not me. Emotional reasoning fallacy. Emotional reasoning fallacy is the error of using our emotions as guides for evaluating the validity of a claim. Findings that challenge our pre-existing beliefs often make us feel uncomfortable or angry, whereas findings that confirm those beliefs often make us happy or to feel relieved. So kind of these are just a few fallacies that I grabbed. So bandwagon is the classic. Everyone believes it, therefore it's true. So in that case, we're arguing about chicken sandwiches. I would just Google who ate what restaurant has sold the most spicy chicken sandwiches, and I would just say, okay, the McDonald's wins. They've sold the most chicken sandwiches, therefore they're the best. So just because a lot of people believe it means it's accurate. Not me fallacy. So basically, you would go through all this. You would learn all scientific thinking. All anecdotes aren't super reliable. You'd be open to that, but then you would say, that's true for them, but not me. And you can usually see this with driving research, where if you ask people in general, hey, are drivers good or bad? Other drivers, good or bad? And they'll say, other drivers, pretty bad. And then you ask them to rate themselves, and they'll all say, I'm pretty good. So the majority of people say that the most other drivers are bad, and the majority of people also say that they are a good driver. So other people are bad at driving, but not me. An emotional reasoning fallacy. So because psychology, literally the study of human behavior, again, it's so consequential because it's like literally our understanding of like what humanity is, and wrapped up in that is in various institutions, secular and non-secular institutions, and thus kind of finding evidence that challenges those pre-existing beliefs can cause people to be uncomfortable and angry, and then kind of seek out information that supports their arguments. So then that you kind of can use confirmation bias as kind of a way to alleviate that anger and, take comfort in the fact that, oh, look, again, I'm correct, the kind of thing. So again, kind of in which then you're really more at risk in kind of today's age with that, where our social media feeds are really just reflections of our own personal beliefs. Who cares? Pseudoscience can be dangerous. There are 3 major reasons to be concerned. Opportunity cost, which basically means by wasting all your time and money on stuff that really doesn't work. Not even just at the individual level. You can imagine like a government spending billions of dollars on research. It's just garbage. You just wasted all that time, all that money that you could be used on something that's actually helpful. Direct harm. So if you have literally incorrect understandings of humanity, it can literally kill someone. So in the case of, you can take the most extreme case wherein like slavery, like our understanding of slaves they're literally not human. They're made up of different elements. Therefore, we'll just do human experimentation on them because they're not human, and we have to kind of understand evolution because they are a different kind of subbreed of human than us. So again, kind of speaking to these real world, massive worldview, life and death consequences, and the inability to think scientifically, which really just beyond like consequences, considering the fact that we exist in a social world and kind of have to deal with each other. Trying to come to kind of collective solutions with individuals who are primarily only relying on anecdotes. Not that anecdotes are always like 100% incorrect, but again, you have to consider that anecdotes can be widely diverging, and thus how do you handle competing anecdotes, and theoretically be to test this in a systematic way. So really trying to navigate the world, making any kind of collective decision as a group of people, as a country, a state, a neighborhood, a family, can be quite challenging in the absence of kind of scientific thinking. And then this kind of delves into it. Scientific thinking skills aren't just important for psychology claims, but can apply throughout the entirety of our lives. And that's really kind of a big thing that I want you to take, especially if you, if you are not already tired of me, and then continue with my developmental psychology course. Something I really want you to take from this is that these skills that I'm hoping that I'm helping you develop can be used throughout your life. So going back to like kind of the research that we'll look at and our discussion boards that we look at. Those resources, those database of scientific articles exist. You can reach them. You can read on any topic in any journal article, on any field, not just psychology. So having the ability to increase your scientific literacy, to understand what's being written, to understand how to find sources is a lifelong tool that you can use to learn not just psychology throughout your life, but literally any scientific field. There's massive databases of scientific articles for, whatever, biology, neuroscience, anything, sociology, psychology, etc. Scientific skepticism. This is defined as the approach of evaluating all claims with an open mind, but insisting on persuasive evidence before accepting them. Being scientifically skeptical does not mean being closed-minded. Skeptics are willing to change their mind, but must have good evidence before doing so. Everyday life, we're often forced to accept the world of authorities simply because we don't possess the expertise, time, and resources to evaluate every claim on our own. So kind of the idea here is that we're skeptical, but that does not mean that we're unable to change our mind, because it's kind of a scientific process wherein we have new data can increase our understanding, and thus kind of you should update your beliefs, especially when you're kind of at a younger level where you really don't have a lot of experience reading really much of anything. Having that open mind can be quite beneficial. Now, I'll say that being too open-minded doesn't mean that, I'm just going to accept everything kind of thing, obviously. You have to insist on persuasive evidence, and weighing that evidence is a skill that's very difficult to do. But again, ultimately, in the real world, we exist in the real world. I'm driving down the street and I'm crossing a bridge. I'm assuming, kind of risky, considering our infrastructure, that the bridge is not going to collapse. I'm on this elevator. The elevator is not going to free fall me off a cliff. We live in the real world, and it's impossible to be experts on everything, let alone on basically a single thing. As someone who spent a PhD in a subject, I often feel like I know absolutely nothing in the thing that I've spent 15 years studying. So you have to rely on other people's time, experts, and resources. But at the same time, kind of evaluating kind of the underlying assumptions of expertise. So, for example, if I'm a psychologist, and I was like, okay, to do really well in this course, I need you. The only way to be the research shows that in order for you to do well in this course, you have to bring me chocolate chip cookies every single day to my office. Now, I'm an expert. It may work, but I think you should be kind of skeptical about that claim. So kind of examining the underlying assumptions or motivations for certain claims from authorities is warranted. But obviously, as stated, we kind of exist in the real world, and we do have to rely on some levels of expertise of other people. There will be 6 scientific thinking principles which will be emphasized in this course and really all my courses. First, rule out rival hypothesis. Have important alternate explanations for findings been considered. Correlation isn't causation. Can we be sure that A causes B? And falsifiability. Can the claim be disproven? So rule out rival hypothesis. So for example, again, I go to start my car and the car doesn't work, and I was like, man, this car doesn't start because I'm wearing my unlucky t-shirt. That's the reason why my car starts. Well, it also might be that I have not replaced my oil in 3 years, for example. So rolling out those rival hypotheses before kind of coming to more sensational claims. Correlation isn't causation. You can see on the right-hand side here, just a classic finding that the age of Miss America contestants being correlated with the amount of murders within an area, or death from basically like steam. And you can see here, looking at these two lines, they're pretty. There's a relationship here. However, just because something's correlated does not mean it causes something. Things can naturally occur at the same time in the real world, and they actually aren't really influencing each other in any way. In this case, the age of Miss America from 1999 to 2009, with the rates of murder from steam and hot objects and hot vapors. And falsifiability, can the claim be disproven? So I can make any claim. I can say, for example, the mail is being delivered by aliens from whatever. But scientifically, the question then is, how can I challenge that hypothesis? How can I reject that explanation of a hypothesis? And you can't, because I can't find these aliens that are delivering my mail. So in order for something to be scientific, it has to be able to be challenged through evidence. It has to be falsifiable, which is kind of the idea of can it be can a science experiment indicate that hypothesis, that theory, is false. And if it cannot, then it's scientifically worthless, because I can't rule it. I can't rule it out. I can't work with that argument. It has to be testable. Replicability. I was only in speech for, I don't know, how long? Over 10 years. Anyway, so we're trying to replicate studies. When a study's, and this is defined as, when a study's findings are able to be duplicated, ideally by independent investigators. If researchers' findings can't be duplicated, it increases the odds that the original findings were the result of chance. We shouldn't take too much stock in a psychological finding until it's been replicated. An attempt to replicate 100 published studies in Social and Cognitive Psychological Journal found that only about 40% of the original findings could be replicated. So basically what this is getting at here is that just because one study finds something doesn't mean, okay, well, that's settled science, because it's going back to those levels of analysis, it's very difficult to come to a definitive conclusion about anything from a single study. So really what you need is a bunch of studies kind of finding similar results to kind of give you confidence in those results. So kind of the more studies that support, or I should say the more results from studies support a kind of a general idea, a general understanding of psychology, the stronger that claim can be. And interestingly, there's kind of been an effort to see, okay, can these big cliche, these seminal studies in psychology, can they actually be replicated? Are they consistent? Are those findings consistent across time? And interestingly, researchers have typically found they aren't, which kind of reflects how difficult it is to study psychology. And there's a whole bunch of reasons why. And one of the reasons why is because research is predominantly in kind of Western suburban context. So kind of going back to that, one of our limitations of kind of anecdotes, where are asking how representative the cases are, you have to ask yourself how representative your samples are to the world population. And drawing huge world populations, huge human behavior claims are very challenging because of the impact of culture, of neighborhoods, of historical periods, of political and social and economic differences. So before kind of saying, okay, this X1 study found this, it's important to keep in mind, okay, but what did other studies find? And because I guarantee you, researchers are constantly arguing about fields. They have different about findings. They have different theories. They have different operational definitions, and you have to kind of consider all these things. And obviously, that can be quite challenging. Extraordinary claims require extraordinary evidence. Is the evidence as convincing as the claims? So I can say, no, the Bigfoot lives in Panama City, and he's the reason why the roads are so poorly constructed in Panama City. And I don't know, it might be true, but more likely it's just that there's other issues in the area, other infrastructural issues that are driving this. not that Bigfoot. So not that Bigfoot is breaking the roads in Panama City. So the more extraordinary the claims, the more extraordinary evidence that you need to support your claims. Occam's razor: does a simpler explanation fit the data just as well? Your friend who has poor vision claims that he spotted a UFO while attending a Frisbee tournament. So is that friend right? Maybe. But kind of the simpler explanation using Occam's razor, the simplest explanation for the data is probably just, hey, your friend is kind of like, has very bad vision, and they probably saw a cloud, and they think it's a UFO. All right, so we covered some fallacies, we discussed about pseudoscience, but now let's talk about psychology more as a science. Psychology is intimately familiar to all of us. Memory, learning, love, sleep, and dreams, personality are all part of our everyday lives. Because these psychological phenomena are so recognizable to us, we may assume that we understand them. Systematic approach to evidence. Science consists of a set of attitudes and skills designed to prevent us from fooling ourselves and fooling others. Science begins with empiricism, the premise that knowledge should initially be acquired through observation. Science refines our initial observations, subjects them to stringent tests to determine whether they are accurate. Observations that stand up to rigorous scrutiny are retained. Those that don't are revised or discarded. So we already reviewed this, really. So psychology is so intimately familiar with us. We exist in the real world. We have interactions with other people, and we're trying to understand why people do the things they do, because I'm irritated with them or because I love them. So I'm going to try and form conclusions. So it's very understandable that we're going to make assumptions about behavior. Psychology uses, though, a scientific approach because we want to take a systematic approach to evidence to give us a better understanding of behavior for our own understanding, and also so you can design like public policy programs, to design better therapy sessions. You know, it ranges from a government policy all the way down to understanding how to interact with my friend in a more helpful way. Or in a more positive way, I should say. Science begins with empiricism. You'll hear me say empirical a lot, and kind of the idea here is that the argument to science is that knowledge begins with observation. However, it's not just anecdotal observations, but rather kind of using the scientific method, using a series of stringent tests to determine whether the observations we are observing in a scientific way are actually representative or of anything. Can we draw any conclusions based on those observations by using the scientific method? I also want to give you some basic definitional terms here. Again, kind of operationally defining our terms. Beginning with scientific theory. It's an explanation of a large number of findings in a natural world, including the psychological world, ties multiple observations together into one pretty package/narrative. Good scientific theories should do more than account for existing data. They generate predictions regarding new data we haven't yet observed. For a theory to be scientific, it must lead to novel predictions that researchers can test. Okay, so kind of the idea here is that, clarification here is needed because theory is just thrown around like everything. Theory, hypothesis, these terms mean basically the same thing or nothing to most people. But really what theory means is a way of, again, to tie multiple observations together into one kind of single narrative. So, and it's used to generate predictions as stated. So the idea here is we have, for example, thousands of research findings, right? And I'm looking over this entire research findings. And what I'm trying to do here is come up with one kind of explanation that is explaining all those research results. So I'm a prenatal theorist. All that matters is prenatal development. So that's my general explanation. And then I can have a specific hypothesis that says, okay, mothers who are exposed to, or I should say fetuses who are exposed to more stress from their mother during pregnancy are more likely to be disruptive as toddlers. So that's a specific hypothesis. So my general explanation for the world is that prenatal development, prenatal stress affects all developmental outcomes. And then my specific hypothesis is, in this case, that children who are fetuses who are exposed to higher levels of prenatal stress are more likely to exhibit externalizing disruptive behaviors as toddlers. than fetuses from mothers who were not stressed during pregnancy. So a specific hypothesis derived, generated from my theory, and based on those results, if, oh wait, the non-stressed mothers actually had children who were more disruptive as a toddler, then I would say, oh, I guess my theory is, something's wrong with my theory, so I should either revise my theory or outright reject it. And that's kind of how that works. And one misconception I want to talk about theories is that kind of this idea that theories are just guesses about how the world works. It's just a theory. But all general scientific explanations of how the world works are theories. For example, the Big Bang Theory. So they propose how the universe began based on all these these various observations of findings about the universe. And kind of the idea here is that through the collection of all these findings, we have this general explanation of what happened. So we have all these individual, like, galaxies are rushing away from each other, telescopes revealing when the Big Bang or when the galaxies were formed. So really just the point being here that we have all this evidence that supports this idea of a Big Bang theory. Thus, all the evidence points to that as kind of the best explanation. It can never be proven. You're never going to go back 14 billion years ago and see, oh, when was this made? Theories in general cannot be proven. Their theories are rarely laws. We have theory of gravity. Theory does not just mean this random guess, but rather, again, kind of this theoretically, depending on the field, thousands of pieces of evidence of results, and then trying to come to kind of a global general explanation for those results is kind of the basis of a theory. Now I'm just going to briefly touch on these different old school kind of approaches to psychology, first being structuralism. They really ask what type of questions. That is, what is consciousness thought, or what is conscious thought like? And basically what their goal was to create or identify the basic fundamental aspects of psychological experiences. So create kind of a basic element charts of consciousness, feelings, images, sensations, kind of like a periodic table. So kind of looking at people's behaviors and trying to come to kind of global conclusion based on watching people's behaviors. Or even looking at your own behaviors, partaking in introspection. So kind of thinking through why I'm doing something, what is going on. But that is obviously very subjective, and it proved ultimately to be kind of a very difficult task, creating kind of this periodic table of basic sensations. So for example, you can have these same structuralist psychologists would look at the same behaviors, and then kind of do their breakdown of, okay, what is causing this behavior, and they would form wildly different conclusions, because that's kind of a very subjective way to go about researching, especially introversion. Kind of, it's my own understanding why it is that you do what you do can be quite difficult, and people can come to different conclusions based on what they did. So it's kind of, they can be subjective and difficult to determine. Okay, but whose account is correct? There's also, actually, we're not going to test on that. I'm going to go ahead and delete that. Let's move forward to functionalism. Okay, functionalism. Major figure was William James, heavily influenced by Charles Darwin. He focused on why, or functionalism, I should say, focuses on why versus what. Why do we sometimes forget things, for example? They are influenced by the work of natural selection, which emphasizes that physical and behavioral characteristics evolve because they increases the chances of their survival and reproduction. Functionalists argue that Darwin's theory applied to psychology. Psychologists serve as kind of a detective role, figuring out that the evolved functions that psychological characteristics serve for organisms. Hope to understand the adaptive purposes of thought and behavior. So why is this behavior occurring? What evolutionary advantage did this behavior support? And this can be very difficult because trying to figure out, oh, why did this human evolve this thing, the tens of thousands of years ago, can be guesswork at times. You can come to solid conclusions, but also they can really, at times, kind of be biased, because you kind of look at the world around you and say, okay, everything here has to be serving some kind of evolutionary advantage. So what is the evolutionary advantage of whatever, the world around me? And obviously the world around me can be very unjust at times. So then you can kind of end up kind of giving evolutionary or like biological reasons for things that may exist around you, but are really not based on like biology, but really based on these like larger societal questions of like justice and political rights and all these things. But kind of the point here is that they're really influenced by Darwin, and they're trying to figure out why it is that certain psychological outcomes and certain behaviors emerge, or why the brain exists as it does. Why is it this massive thing? Why is it taking up so much energy? Why do we need to sleep, for example? Why do we need friends? What purpose does it show or serve, evolutionarily speaking? Behavioralism, classic one being Watson and Skinner. Basically what they argue is that there are a few general laws and principles of learning that you can to understand psychology. So you can understand all of psychology really just looking at by using these few basic principles of learning, such as rewards and punishments and inputs and outputs. And we'll talk about this later on. But the idea, basically, what they're arguing is that we don't need to peer inside the organism to grasp these principles. We don't need introspection. It's too subjective. It's not scientific. Therefore, we're not even going to look inside the organism at all. All we're going to look at here is human behavior, specifically in rewards and punishments. So it's inputs, outputs. So experimenter can give a rat a piece of chocolate every time it does some maze, and then the rat gets better at the maze through time. That's telling me that the chocolate is helping the rat learn. So kind of more plainly stated, there's a classic experiment wherein like a rat will just keep pressing the cocaine button in a cage, and they'll keep pressing it forever to get that reward. And you can basically manipulate the rat into doing things to get cocaine. So kind of the idea here is that there's inputs, what is cocaine, output, the rat doing whatever behavior you want them to do. What's going on in between that does not matter. Just inputs, outputs. And that's all he focused on. We'll talk about him in more detail later on, but that's kind of just an overview of him. Not concerned with the human brain at all. Cognitive approach, they argue that thinking affects our behavior, focuses on the mental process involved in different aspects of thinking, highlighting the role of thought in our interpretation of events and behavior, interpretation of results or rewards and punishments, insight, understanding the underlying nature of problems. So kind of the idea, going back to Skinner, you can imagine an example wherein I give my fictional daughter $1 every time she earns an A, and then she starts getting A's. And then I come to the conclusion, okay, what actually is driving people is to earn good grades is the fact that I give them $1. But the $1 to a 5-year-old is going to be different is different compared to giving a $1 to a 40-year-old. The dollar has less meaning. The interpretation of that reward is different. Thus, you have to investigate how thinking, the impact of thinking, of mental processes on behavior, because interpretation of stimuli matters. But that's just one example. As I stated before, kind of going back to that bullying, the feedback, wherein I give you the same feedback as someone else, and then one person says, oh, I love that feedback, and the other person's like, oh, I hate this feedback, screw this guy. So kind of the interpretation, thinking, affects our behaviors, is basically what they argue. And ultimately, kind of like bodied ended behavioralism as kind of as the dominant field of psychology about 60, 70 years ago. Then we have Freud, psychoanalysts, which is Freud, Jung, classic, what people are aware of. They're focusing on kind of the exact opposite, the internal psychological processes of which we're unaware, memories, thoughts, impulses. I should say the opposite of Skinner. So kind of their idea is that we have these unconscious impulses that are outside of our awareness, and those are actually what are driving behaviors. And usually for Freud, it's kind of like sexual nature, and it's impulses and unconscious behaviors that really developed in the first couple years of life, or first 5 years of life. So wrapping up, popular psychology. There are about 3,500 self-help books published each year. However, only 5% of these books are actually tested. The quality of information could be good, bad, or even harmful. There are many different kinds of fields of psychology, or psychologists, I should say, studying all kinds of things from addiction to war to adolescent development to how to drive safely, trauma, stress, racism, etc. So psychology is this very broad field with a lot of interest. However, pop psychology in general is not very scientific, and can often be misleading or even harmful depending on the claims made. So some conclusions: learning to think scientifically will help you make better decisions not only in this course, but in everyday life, and restructure societies based on how we think people should act and how we want them to act. All right, with that said, thank you so much for listening. I hope you have a great week, and I will see you next week.